Now, there are three very important properties that all logarithms possess. These are three foundation, they're incredibly important. They get used very frequently. These are properties that all logarithms possess. Irrespective of the base, all logarithms possess these properties. And there are three of them. The first is this. It says log base b. The base may be any valid base. Log base b of x plus log base b of y. Now you might think that if you add the logarithms, that's the same thing as the log of x plus y. That is not correct. Log base b of x plus log base b of y is log base b of x times y. That is not obvious, and I'm not going to go work our way through a proof of that statement, but that is, in fact, that's correct. This is the only function, logarithms are the only functions for which this property holds. This says, if you take the log of one number and the log of another number and add them together, that's the same thing as if you take the log of the two numbers multiplied together. This is not an obvious property, but it is correct, and we will forego the process of going through proving this thing to be true. It is, however, the case that if, for example, if I took log base b of 5 plus log base b of 2, if this is x is 5 and y is 2, then if you add those together, that's the same thing as taking 5 times 2. So the log of 5 plus the log of 2 is the log of 10. If x were 3 and y is 8, if this is 3 and y is 8, then the log of 3 plus the log of 8 is the log of 24, 8 times. So you multiply the arguments. The sum of the logs is the product of the arguments. The sum of the logs is the product of the arguments. The second is like it. Now, I haven't proven this, but we are going to accept that as an established fact. The second is very similar. If you accept the first, the second shouldn't be too much of a hassle. This says if you add the logarithms, you multiply the product. The second property says if you subtract the logarithms, and as you might imagine, if you subtract the logarithms, you divide. You divide the arguments. Roughly speaking, any logarithm with a negative in front of it, that argument goes to denominator. Any logarithm with a plus, if there's no plus, we assume this is plus. Any logarithm with a plus in front of it, we assume that argument goes in the numerator. And then the third property is similar, third property is, again, it comes from the properties of exponents where these do. And again, we won't go through a proof of this, but the third property is the one that gets some mileage out of this. And it says this. If you take the log, and again, it can be any base, the log of any base, if you have x raised to some power, if I have log base b, and this can be any expression raised to a power, then what you may do is write log base b of x. The exponent may be rewritten as a coefficient. Now, the reason this happens is, or a way to think of why this happens, is that really at their core, and this is not obvious to see, but really at their core, logarithms are exponents. When you compute a logarithm on your calculator, the answer being given to you is an exponent. If you find the natural log of 5, that number is an exponent. Logarithms are exponents, and so they inherit their properties from the properties of exponents. And it's not exactly this, but you can see where they inherit the property from. Remember that when you multiply the bases, you add the exponents. Well, that's kind of what's happening here. When you multiply, you add. That's the principle behind this property. We know when you divide the bases, you subtract the exponents. Well, when you divide, you subtract. And then we also know that when you raise a power to a power, if you take an exponent, raise it to a power. If I take x raised to the second raised to the third, that's x to the sixth power, because the power to a power you multiply. Well, what we're essentially doing is we're taking a logarithm. It's not exactly this, but you can think of it this way. This is a logarithm where you're taking it, raising it to a power, and a power to a power you multiply. Again, this isn't exactly these properties, but these are the principles from which these properties inherit their behavior. And so when you multiply, you add the exponents. When you divide the bases, you subtract the exponents. When you raise a power to a power, you multiply. And so that's the principles behind these, even though that's not it explicitly. That's where these properties come from. Now, what this allows us to do is to take large expressions with several logarithms and rewrite them as a single log. It also allows us to take a single logarithm and expand it out into several smaller logarithms. Depending upon what you need for your particular problem, you need to be versed in both of those procedures. And so the next video, we'll talk about that process. But that's how these properties get used, is manipulating these logarithms so that if what you have isn't what you need, then you know how to manipulate them to make them become what you want. The last detail is this. When you apply property number 1 and property number 2, those bases must be the same. If we have log base 3 on this, and this is log base 4, then they do not combine, at least not in this form. Similarly, when you're doing property number 2, that base and that base must be the same. If you have log base 5 here and log base maybe 2 here, then in this manner they don't combine. They must be the same base, and the base you end up with must be that common base that you had in the original problem. And so as long as you have those phenomena occurring, then you may apply these properties as you need them.